Work. What is that? What do you think work is? Is that doing work? Is that kid typing on the computer doing work? How about the guy looking through the microscope? Or this guy cutting down a tree? Or this guy throwing dirt over his shoulder? Work means using a force, which we know is a push or a pull, to move an object a distance. So let's look back at those pictures. This kid typing on the computer is doing work because he's using a force to push the keys of the keyboard. This guy cutting down a tree is using a force as he moves his chainsaw through the tree trunk. This guy, however, is not doing work because all he's doing is looking through the microscope. If he were to use his hands to apply force to the knobs on the microscope, then he would be doing work to those knobs. The shoveler is doing work as he lifts the shovel and throws the dirt behind him. But this guy sitting on the tractor, even though it's hard work to be a farmer, he's not doing any work. He's not applying a force in order to move the tractor. It's important to remember when we're talking about scientific work that the force used to move the object must be in the same direction that the object actually moves. So if you push a box on the floor and you push forward and the box moves forward, you've done work. But if you lift a box in the air and walk forward, you're not doing any work on the box anymore because the box is moving forward, but your force on the box is going up toward the ceiling in order to hold it up. So let's take a look at these. Is work being done or not when this person is mowing the lawn? How about when this woman is holding a bag of groceries? Or moving furniture up a flight of stairs? Or pushing against a locked door? Or swinging a golf club? Well, mowing the lawn is doing work because you're applying a force to the lawnmower and making it move forward. Holding a bag of groceries is not doing work because the force in the direction of motion, if this woman is even moving, is not the same. Moving furniture up a flight of stairs is work. Pushing against a locked door, no matter how hard you push, even if your muscles get tired, that's not work. And swinging a golf club is work. So the key thing to remember about work is if the object moves in the direction of the force, work is being done. If the object doesn't move, no matter how tired you are, or if the direction of the force and the direction of movement are not the same, no work is being done according to our scientific definition. Now let's talk about calculating work. The formula for work is force times distance. Remember that all or part of the force must act in the direction of movement. Do you do more work when you finish a job quickly? No, work does not involve any amount of time, only force and distance. So no matter how fast you clean your room, you've done the same amount of work. You've moved the same objects, the same distance, requiring the same amount of force. No work is done when you stand in place holding an object. So you could be holding 30 pounds of bricks and it might make you really tired, but you're not doing any work to those bricks. As we said, the formula for work is work, represented with a W, equals force, capital F, times distance, lowercase d. The units for work kind of get complicated. The units for work are a Newton times a meter because the formula for work says force is measured in newtons, times distance is measured in meters, so that means the units are a Newton meter, which can also be represented as a kilogram times a meter per second squared times a meter. In honor of a scientist who did important work on the topic of work, this unit is named the joule. The joule is 1 Newton meter. It's abbreviated by capital J since it's named after a person. That person was British physicist James Prescott Joule. Hopefully this clarifies what work is according to the world of science. Make sure you answer your questions and submit your Word document.